All right, let's talk about one of the wildest paradoxes in all of engineering. We're going to look at a ship that has to do the one thing a ship should never, ever do. It has to sink. And it does this to pull off some of the most mind-blowing rescues and transports you've ever seen. It's an absolutely brilliant solution to what looks like an impossible problem. So let's get right into it.
So, let's set the scene with a real-world crisis. It's October 2000, and the USS Cole, a massive 9,000-ton destroyer, has just been attacked in the Gulf of Aden. I mean, this thing is crippled, it's taken on water, and it's thousands of miles from any port that could possibly fix it. So here's the question. How on earth do you move a sinking giant like that clear across an ocean?
Right off the bat, it was obvious that all the usual rescue methods were just completely off the table. No way. The sheer scale of this problem, it was going to need something truly extraordinary.
I mean, just look at this mismatch. It's almost comical. Your average harbor crane, maybe it can lift a couple hundred tons. The really, really big ones might get up to a few thousand. But we're talking about the USS Cole here. That's almost 10,000 tons. And it's not like it was sitting nicely in a calm harbor. Nope, it was crippled out in the open ocean. So lifting it from above, that was never, ever going to work.
Okay, so if you can't lift it from above, what's the plan? Well, the answer comes from a completely different direction. In fact, it comes from a ship that does something, well, something no ship is ever supposed to do.
And here she is. Meet the hero of our story, the Semi-Submersible Heavy Lift Ship. This is a special kind of vessel, designed specifically to carry unbelievably heavy floating objects. We're talking giant oil rigs, or, an entire warship. And the specific ship that got the call to rescue the USS Cole was the legendary Blue Marlin.
And this right here is the absolute genius of it. It's the core paradox of how this whole thing works. The idea is so simple, it's almost, well, it's just brilliant. To get its massive cargo on board, this ship has to do the one thing every sailor spends their entire life trying to avoid. It has to sink. On purpose.
So, you're probably wondering, how exactly does a ship sink itself to save another one? Well, the mechanics are like this elegant four-step dance between engineering and physics. Let's break it all down. Okay, so it's a four-step process. First up, submerge. They flood these massive ballast tanks with seawater, which sinks the main cargo deck right down below the waves. Step 2, position. The USS Cole is then carefully, very carefully, floated into place right over that submerged deck. Now for step 3, deballast. This is where the magic happens. They start pumping all that water out of the tanks. As they do, the ship's own natural buoyancy takes over, and it starts to rise, lifting the entire 9,000-ton destroyer right out of the sea. And finally, step 4, transport. Once it's high and dry, they secure the road, and you are ready to sail.
Yeah, the USS Cole rescue was super dramatic for sure. But believe it or not, these ships can handle even bigger jobs. While the Cole fit pretty neatly on the Blue Marlin's deck, check out the HMS Canberra. Its hull was so long it was literally hanging off the back. And that just goes to show you, it's not just about fitting the cargo on the deck, it's all about precise weight distribution. As long as that load is balanced perfectly, the ship can carry it.
Okay, so moving damaged warships around the globe is pretty dramatic, right? It makes for amazing pictures and great headlines. But what if I told you that this isn't even the main reason these incredible ships were built in the first place?
Yeah, you heard me right. Rescuing billion-dollar destroyers? That's basically a side hustle for these ships. Their primary job, the thing they do day in and day out, was designed for a totally different industry. They were built to move the real titans of the sea, those massive offshore oil and gas platforms.
So why is this so important? Well, just think about it. Imagine you build a gigantic oil rig in, say, South Korea, but you need it over in the Gulf of Mexico. The old way to do it was to just tow it, and that is incredibly slow. We're talking a few knots for weeks and weeks on end. You're exposed to terrible weather, pirates, all kinds of political risks. But a heavy lift ship, it just scoops up that same rig, travels at normal shipping speeds with one crew, and gets it there way faster and a whole lot safer. The amount of money this saves is just massive.
And the scale we're talking about here is just staggering. It's hard to even wrap your head around it. The Blue Marlin can haul over 75,000 tons. But guess what? Even she's been outdone. Today, the biggest ship of this type is the Vanguard, a vessel so enormous, they actually considered using it to salvage the Costa Concordia cruise ship. Just think about that.
Okay, so now that you know what these amazing things are, how can you spot one out in the wild?
If you're ever near a big port or watching ships go by, they have a really distinct profile that makes them pretty easy to identify, if you know what to look for, that is.
So here's your ship spotter's checklist. Number 1, look for a massive, flat, and totally open cargo deck. It almost looks like an aircraft carrier that's missing its tower. And number 2, and this is the dead giveaway, look for 2 big upright structures at the very back of the ship. Those are called the buoyancy casings. So what's the deal with those big casings? The best way to think about them is like giant water wings, but for the ship itself. See, when that main deck goes underwater, the rest of the ship naturally wants to follow it down. These casings provide just enough extra buoyancy at the stern to keep the whole vessel stable and level. Honestly, without them, the entire operation would be way too dangerous. They're the secret sauce that makes this whole incredible process work.
And that pretty much brings us full circle. We've seen this amazing technology that was born out of the needs of one industry that then turned out to be the perfect solution for incredible feats in a totally different one. It really makes you wonder, doesn't it? If we can already move entire floating structures the size of city blocks clear across the planet, what's the next impossible thing we're going to figure out how to transport?